Okay, so we're going to carry on with our proving trig identities. I'm going to do a few more examples for you. And as I said, the level of difficulty will increase with each of these as we move on. All right, so first example for this one. So I'm going to do two examples here. We'll take tan squared x minus sine squared x. And that's supposed to equal sine squared x times tan squared x. All right, first thing you have to do is decide which of these two sides, the left side or the right side, do you want to work with. A quick glance shows us that both sides are very, very similar. Same thing on both sides, the same terms, except on the left side we have the terms separated by a subtraction sign. On the right side, it's multiplication. All right, when you're choosing something like this, my suggestion is always go with the side that has either a subtraction or a plus sign on it. Much easier to go from this over to this one than the reverse. So we're going to start with the left side. So again, you write left side equals, put down exactly what's there. So we have that. All right, one of the other rules that I told you, one of the techniques of solving, is anything that's not written in terms of sine and cos, you want to write it that way. So this one is not. So that tells me the first move, let's get rid of this. Well, tan squared x is the same thing as sine squared x or cos squared x. Keep the minus sine squared x. When you get to this point, you don't panic and say, what do I do here? You look at this and say, oh, I have a fraction. And I'm taking off something else. Whether it's a fraction, you're adding or taking off something, think common denominators. So the common denominator here, since this is a cos squared x and this is just simply sitting over 1, it will be our cos squared x. So we'll just put one great big line here and put cos squared x under it. This sine squared x is already over the common denominator, so it stays. Put down the subtraction sign. Again, under any term, if there's nothing written, it's the number 1. To go from 1 to cos squared x, you had to multiply by cos squared x. So you do the same thing with the sine squared. So it becomes sine squared x, cos squared x. So we have that. Then, at this point, notice what we have here. We have a common factor. I have a sine squared in both of these. We're going to factor that out. So we're going to take out the sine squared x. When you factor sine squared x out of here, you're left with a 1. When you take it out of this expression, if you take that out, you're simply left with the cos squared x. And we're still sitting over cos squared x. Then, at this point, what I have here, okay, and again, keep looking at the other side. This is a sine squared x. I'm going to leave that alone. But this, 1 minus cos squared x, is also sine squared x. So we have that. Now, I could call this cos to the 4x, but I don't want to do that. Okay, I want to keep it like this. And the reason for that is now I can break these down into two separate things. I can group these two together, and sine squared x over cos squared x is simply tan squared x, and it's being multiplied by this sine squared x, which if we do a quick little look on the other side, there's our right side. So we've gone from the left side and we've turned it into the right side. And again, at this point, you could have called this sine x to the degree 4, but we don't want to do that. Okay, looking on the other side, notice everything is in terms of squares. So you can separate these. The 1 goes with the cos squared x, which gives us tan squared x, and then simply times the other one, and you have exactly what's over on the other side. All right, so that's a first example. Let's try one more. All right, so for a second example for this video, let's take this time cos x tan squared x, and that's supposed to be, oh, excuse me, not tan squared x, I want to change that. Let's call it tan cube x, and that's supposed to equal sine x tan squared x. All right, again, when we look at these, they appear to be fairly similar. Okay, we have a cos with a tan 3, a sine with a tan squared. All right, in given a situation like this, you want to go with the one that has the higher degree. Easier to go from a higher degree back down to a smaller one than the reverse. All right, so we'll go with our left side. So left side equals, again, write down exactly what's there. Now, a little look at this one. Again, do not ignore what's over on the right side. Okay, remember that's what you want to get to. So I want to get a tan squared x. So what I'm going to do at this point, normally I would say change anything that's not in terms of sine and cos and turn it into that. In this particular case, I'm going to hold off on that for a minute. I'm going to write this as cos x tan x tan squared x. What I've done now is I've brought in the one that I need. Okay, there's my tan squared x. It's now this stuff that I want to change. Okay, I don't want to get rid of this one. It's on the right side. So let's just play around with this. At this point, this is where I'll say, okay, now this isn't in terms of sine and cos. I want to change it. So leave this cos x. Tan x is the same thing as sine x over cos x. And then we still have this tan squared x. This is all multiplying and dividing. So when you see something in the numerator position that's exactly the same as something in the denominator position, they wipe each other out. And then all we're left with is this sine x along with the tan squared x, which we can clearly see is our right side. So again, we've gone from the left side and we've turned it into the right side. Again, given the choice, when you're deciding which side is the messy one, which side should we start with, always go with the one that has the higher degree. Easier to go from a higher degree down to a lower one, and the trick here, just separate them. Okay, a tan x times tan squared is your tan cubed, but this brings in the term that we're looking for already on the right side. Okay, so there's two examples for today. Hopefully those help. I'm going to do one more little video in a second, and I'm going to do two last examples to try to show some other techniques that you can use to solve these. All right.